So can anybody give me an example of equivalent measurements? Yeah, 1 cubic centimeter is 1 milliliter. Those are equivalent measurements. Equivalent measurements, there are two things that are the same. So got to start off with two things that are the same. So that's what they mean by equivalent measurements. And then we have to turn them into a ratio. So yesterday we learned that 1 meter is 100 centimeters. That's our equivalence. Those things are equivalent. Now we need to change them into ratios. Okay? And the way you change them into ratios is divide. And what I'm going to divide is I'm going to divide both sides by the other to come up with two ways of writing the number 1. It's always hard to write about doing math. It's easier to show you doing math. Okay. So I'm going to do that division and come up with two ways of writing the number 1. Okay. So I'm going to divide both sides by 100 centimeters. Is that okay to do? Okay. What happens on the right side? Got something on 100 centimeters over 100 centimeters. Cancels out and turns into 1. So I have a ratio of equivalent measurements. This is a conversion factor. The thing on the top and the thing on the bottom equal each other. But I said I could do it twice. No, I can. Because I can start here. And divide both sides by the 1 meter. Now, the left side is going to cancel out, and it's 1. So if I have a ratio of equivalent measurements, it is equal to 1. If the thing on the bottom and the thing on the top are the same size, you've got 1. Right? That's not earth-shattering, is it? Okay. So, the unique way to write the number 1. Okay. As long as you're in the same system, they are defined quantities. And remember, definitions have unlimited sig figs. Are there ever going to be 101 centimeters in a meter? No, it's got to be exactly 100 by definition. Okay. And equivalent statements always have this relationship. The big number goes next to the small unit, and the small number goes next to the big unit. Talked about this yesterday. Talked about it in terms of scientific notation. The big number has a small exponent, the small number has the big exponent. For example, 1,000 millimeters is 1 meter. So my conversion factor is going to have that too. The big number is going to be next to the small unit. The small number is going to be next to the big unit, and they're going to be on top of each other. That big and small, that's going to work all the time. So, write the conversion factors for kilograms to grams. kilograms and grams. So I need a ratio of equivalent measurements. So I need to start off with what's equal with kilograms and grams. And 1 in 1,000, there's a 1 equals 1,000. Which one's the 1, which one's the 1,000? A kilogram is big, so it equals 1,000 grams. The big unit gets the small number. So now I turn that into conversion factors. What conversion factors can I make? Well, that's 1 kilogram over 1,000 grams, or 1,000 grams over 1 kilogram. So I find two things are equal, put one on top of the other. Now, conversion factors, I've used metric examples, but it doesn't have to be metric. Any two things you can get equal to each other. If you get two things equal to each other, you can write conversion factors. So write the conversion factors for feet and inches. Now, some of you might ask, what's the equal statement? Mr. Green, how many inches are there in a foot, or how many foot are the inches? And if you come to me in the middle of the test and ask me that question, you know what I'll say? I'll say 12 inches is 1 foot. Because I don't care if you know the English system. But if you come to me and ask me, Mr. Green, how many grams are in a kilogram, or how many kilograms in a gram, that one I won't tell you. You should know that one. So I care if you know the metric system. I don't care if you know the English system. Okay. So since I know that, then 1 foot over 12 inches, or 12 inches over 1 foot, and all of those equal 1. Because they're all got the same thing on the top and thing on the bottom are the same size. Earth-shattering? No. So. Why are they good for? I mean, I could write them, but there's got to be a purpose to it. Well, their name is conversion factors because they convert. Okay? The way they're going to convert is we're going to multiply by 1 creatively. We get to create our 1 to change the units. Units are your friends. They will set up the problem for you as long as you know things that are equal to each other. Ask this kind of question. 13 inches is how many yards? All I want the 13 inches expressed in a different unit. Okay? So we're going to make a conversion factor, and I need a conversion factor with yards and inches. And 36 inches is 1 yard. Everybody agree? I can make two potential conversion factors out of this. One with inches on top, and one with yards on top. I've got my choice about which one. I'm going to pick this one, and you'll see why in a minute. That my conversion factor I've got here is 1 yard over 36 inches equals 1. So that's my creative 1, and I said I was going to multiply by it. So 13 inches times 1 yard over 36 inches equals if you look carefully, inches on the top and inches on the bottom. The inches cancel out. Why do they cancel out? Because I set them up so that they cancel out. The reason why I picked this conversion factor, because I knew I wanted to get rid of inches. So I picked the one that had inches on the bottom. I had two to choose from. I picked the one that had inches on the bottom. Okay? That means my answer is going to be in yards. Now all I have to do is do my math. 13, the ones on top times 1, I'm not going to push that, divided by 36 equals My calculator says 0.361111, repeating ones. How many sig figs? Well, there's 2 sig figs in 13 inches. And in this conversion factor, why is 1 yard 36 inches? Because that's the definition, right? And if is there ever going to be 37 inches? No. So this has unlimited sig figs. So which is smaller, 2 or unlimited? 2. So with 2 sig figs, my answer would be 0.36 yards. In the same system, conversion factors have unlimited sig figs. And they're called conversion factors because they convert units. I told you I was going to teach you a powerful mathematical technique. This is it, using conversion factors. You can use it to solve a myriad of problems. Okay? Just creatively multiplying by 1. Okay? And the tricky part is choosing the conversion factor. So you choose the conversion factor that gets rid of the unit you don't want. I picked the one that had they gave me inches, so I picked the one that got rid of inches, had inches on the bottom. Because you have one on top, one on the bottom, they cancel out. So I set it up so they were going to cancel out. Okay. So this technique actually has a name, actually has several names. I call it dimensional analysis. Another name for it is the factor label method. And the reason I like the name is because it's explanatory. If you know that dimension is another name for unit, and analyzing is the way to solve the problem, right? One of the ways to solve a problem. So you use the units to solve the problem. The units will set the problem up for you. The units are your friends. So all your classes up to this point, someone's told you have to put the units in and you ignored them or you did it just because they said you had to. Now you're going to see that the units are the ones that are going to set the problem up for you. You're going to solve the problem by focusing on the units. Because if you got the units right, the chances are you did the math right. If you got your units wrong, if your units don't work out correctly, you know you're wrong. If the units don't work out, you did it wrong. And if the units do work out, chances are you did it right. Lauren, it's not reading time. Okay. So with metric units, I need you to know the equivalent statements. And the equivalent statements are pretty basic. We saw 1 kilometer equals 1,000 meters. 1 meter equals 10 decimeters. 100 centimeters. 1,000 millimeters. 10 to the 6th micrometers, and 10 to the 9th nanometers. And if it's not meters, the numbers are the same. Right? This is what we said our prefixes were worth yesterday. Right? This is not new information. I just put it down so I have a 1 and what it equals. Okay? For the 1 usually goes next to meters unless you're talking about kilometers. Okay, so this is just a list of all the equivalent statements. Okay? And if you have a prefix, you want a conversion factor to get rid of that prefix. Because you can use those equivalent statements to put the prefix on the bottom and the base unit on top. Whatever prefix they give you, you can set up a conversion factor that has that prefix on the bottom and the base unit on top. If they give me kilometers, I can put kilometers on the bottom and meters on top. If they give me micrometers, I can put micrometers on the bottom, meters on top. Okay? And again, to add a prefix, use a conversion factor. Because if you're adding a prefix, that means you started off without it. So your conversion factor is going to have the base unit in the bottom and the prefix on top. And once you know where the units go, you can fill in the numbers. Let the units set the problem up for you. That's the key to this. Okay? So, 25 milliliters is how many liters? Okay, so if I look at this, I've got a prefix and I want to get rid of it. Okay, so I'm going to set up a conversion factor. I always put my conversion factors in parentheses so I can find them. It's going to be a fraction, so I draw a line down the middle. And then I ask myself the same questions over and over again. What unit do I want to get rid of? Milliliters. Where does it have to go for me to get rid of it? It's got to go on the bottom if I'm going to get rid of it. Okay? What do I know about milliliters that I can turn it into? I know the base unit. So I can turn milliliters into liters. Which is bigger, a liter or a milliliter? Liter. So the big unit gets the small number, the 1. And the small unit, the milliliter, gets the 1,000. Because we know that equivalent statement. 1 liter is 1,000 milliliters. I set it up so my milliliters cancel out. And I get 0.025 liters. 25 times 1 divided by 1,000. I don't bother pushing the times 1. Numbers on top you multiply, numbers on the bottom you divide. See how the units set that up for me? I didn't have to decide. In the past, you may have tried to memorize whether you divide or multiply. Okay? You'll get lost. Yeah?
Wait, so for the first number, why don't you have to do significant?
I did do significant figures. Yes, 25 has 2 significant figures. The conversion factor is unlimited because it's exact. So 2 and unlimited, I get 2. So as long as we stay metric, as many sig figs as I start with, that's how many sig figs I'm going to end with. As long as I stay metric, I'm okay. And tonight's homework is all metric. All right? Okay. So next one, 5.8 times 10 to the minus 6 millimeters. And that's a tiny number. So since it's a tiny number, it doesn't make sense to say it in millimeters. Instead, I want to say it in nanometers. Okay. So what unit do I want to get rid of? The one I have, millimeters. What they gave me is what I want to get rid of. It's got to go down there. What can I change millimeters into? Can I change millimeters into nanometers? Do you know how many nanometers are in a millimeter off the top of your head? Okay. Don't try to go from prefix to prefix. Go from prefix to base unit. That one you know. I know that one, right? Which is bigger, a meter or a millimeter? Meter. So the meter gets the 1, the millimeter gets the 1,000. Okay, so that gives me 5.6 times 10 to the negative 9th meters. And then I could take that 5.6 times 10 to the negative 9th meters, and I could use another conversion factor. My next conversion factor, what unit do I want to get rid of? I want to get rid of meters, so it goes on the bottom. What can I turn meters into? I can change it into nanometers. I can put the prefix on. Which is bigger, a meter or a nanometer? Meter's bigger, so it gets the 1, and the nanometer gets the 10 to the 9th. Now, if you want to push this into your calculator, you don't want to push 10 to the ninth. Okay? To push this into your calculator, if you feel the need, you would push 5.6 EE negative 9 times, and to get the 10 to the ninth into my calculator, I'm going to push 1 times 10 to the ninth. So instead of pushing 10 to the ninth, I push 1 times 10 to the ninth. Because 1 times 10 to the ninth is the same as 10 to the ninth. And if I do all that, I get 5.6. I didn't do all that actually, because I saw 10 to the ninth and 10 to the minus ninth cancel each other out. Yeah.
How did you get 5.6 times 10 to the negative 9? My calculator gave me 5.8 times 10 to the negative 9.
Oh, you know what? It should be 5.8. I just copied badly. Those would all be 8s. I know what I was thinking about. It's an 8. It's all 8s. Yeah, because it can't change. It's all 1s and 0s, right? So the answer is 5.8. Make sense? Okay, I'm going to save you a step. There's no sense doing 2 separate problems and writing down the answer in the middle. Instead, if the first conversion factor doesn't solve your problem, these cancel out, I can do another conversion factor. And now my second conversion factor is getting rid of meters and wanting nanometers. I can just write that second conversion factor right after the first one. And now my meters have canceled out. Because I divided by 1,000. That means move the 0 3 times. No, that's what I did. So I did the 0 3 times. Okay. So now I can you can do them as 2 separate problems, but why take the time to write an answer in the middle? Now I can just push this in my calculator as 5.8 EE negative 6 divided by 1,000, because it's on the bottom, times 1 E9, and I get my 5.8 nanometers. Thank you so much for making my teaching easier. So I just need another one. It's not enough. Okay, so this is tonight's homework. Okay, and let's work the first couple together so we know when you get home. The front side's this conversions, and the back side is more big stuff. Oops. So let's work these first couple ones so when you get home, remember how to do. So on that first one, it says 46 centimeters. It's got a conversion. It's got place for a conversion factor. I want to get rid of the centimeters, so it's got to go on the bottom. What can I turn centimeters into? Meters. If it doesn't, so every conversion factor should have a base unit in it tonight. So which is bigger? So the meter gets the 1, the centimeter gets the 100, and I get 0.46 meters. 46 divided by 100 is 0.46. You'll see on the second one, I did 2 parentheses. How did I know to do 2 parentheses when we started? Well, it's got to do with the question. I went from prefix to prefix. If there's 2 prefixes, there's 2 conversion factors. 1 to get rid of the prefix, 1 to put the new one on. Does that make sense? So my 499 deciliters, I want to get rid of deciliters. What can I turn deciliters into? Liters. Because 1 liter is 10 deciliters. And deciliters cancel out. Now, what unit do I want to get rid of? Liters. Where does it have to go? At the bottom. That'll make it cancel out. What can I change it into? Well, they asked me for centiliters. Can I go to centiliters? Yep. So that's 1 liter is 100 centiliters. Liters are gone, so I'd push 499 divided by 10 times 100, and I'd get 4,990 centiliters. Make sense? It's 100. It's 100. 100 centiliters. Sorry, my handwriting's awful. But so yeah, we start writing hundreds a bunch. They tend to hook together. Okay, so you've got the homework. The front side's the new stuff. The back side's the old stuff. And I will see your parents esta noche and you tomorrow. Did you get taken care of? Okay, good.
In the last problem, after we multiply by 10, do we have to multiply by 100? Or
Divide by 100, because where was the 100 at? Okay, so numbers on, so we had 10 deciliters is 1 liter, so I divide by the 10. And then I had 1 liter is 100 centiliters, so I multiply by the 100, because 100's on top. Numbers on top, you multiply. Numbers on the bottom, you divide.
okay,
So you push 499 divided by 10 times 100.
thank you.
Yep.